So solving two-step equations is pretty much the same thing as solving one-step equations. It's just when you use principles of equality, still the same four principles of equality, except you're going to be using two of them from now on. All right. Usually, it's one either addition or subtraction, and then it's either multiplication or division. All right. I'm a math teacher. It's mental abuse to humans, man. All right. What is a solution? So with equations, okay, and we'll look at some examples here. Just understand, because a lot of students, when you guys solve equations, you don't actually think about the solution being, or the answer being a solution to an equation. That makes the equation true, okay? So you'll see the statements more like this: solve for x, or just solve, okay? But what it really means is what value of x will make the equation true. So a true statement means that we're going to be comparing values, okay? So this is mathematically how we would actually solve these types of problems, with what we call principles of equality. So it's just manipulation of equations, that's it. It's really just math manipulation. As it turns out, we can take math and manipulate it as long as we maintain equality. And that's the whole purpose of the principles of equality, is to maintain equality. Now this is very abstract. So right here where it says, look, if you got A equals B, and you know they're equal, then you can add whatever you want to both sides as long as it's the same thing, which is why we got C right there, right? We took two values that were equal, and yeah, of course you may be wondering, well, why are they different letters? That's part of the abstract of math and math theory stuff. It allows us to show differences while showing sameness. Whatever. As long as you add the same thing to both sides, you're good. Or subtraction. As long as you subtract the same thing from both sides. I'm sorry, I keep saying both sides. I mean both sides of the equal sign. As long as you do the same thing to both sides of the equal sign, you're good. Seems like there's other ways that teachers say this, like, well, I guess whatever you do to one side of the equal sign, you got to do the other side as well. Okay, and the same thing works for multiplication. If you multiply A by C, then you got to multiply the other side of the equal sign by C as well. Same with division as well, right here at the bottom. So if you divide by C on both sides, you got to divide by C on both sides. On one side by both sides. You know what I mean. So these four basic operations, that's all we're going to deal with now. We'll get into square roots and exponents later. Okay, but for now, all we got to worry about are pretty much these four operations when we solve equations. And if we can get this down, while remembering that a solution to an equation will make the actual statement a true statement, then as it turns out, there's actually no limit as far as to how far you guys can go. Like if you guys understand this concept right now, I would say that you guys could do calculus. Don't cut yourself short on that. There. So at the bottom it says, with one-step equations, we only need one of these, but in 1.2 we're going to find that we're going to need more of them. Let me demonstrate the principles of equality. I'll try to do it with something that we're familiar with, like addition, okay? So to go back to the top there, it says manipulating equations is what we want it to be. So if I started with something like 10 equals 10, and I said, is that a true statement? You guys be like, dude, I know that's a true statement. I've seen it so often, or I just know it so well. It's like, that's cool, man. Not only do they look the same, but they actually are the same. They're equal. Equal means sameness, right? But what else does 10 equal? So let's say that I didn't want 10, right? Let's say I wanted something else. Now, I'm using the equal sign, which means I need to have something that is actually the same. But I don't want to show it as 10. Well, I could show it as 6 plus 4, couldn't I? See how I manipulated what was 10 into something different? And just this ability also to split things up and to separate things into something that's equal is crucial in mathematics, not only in 980, but in whatever classes you can take. And again, I'm telling you guys, if you can do this, then you can go as far as you want in mathematics. At least that's been my experience with pretty much this individual principle right here. So right now I got 10 equals 6 plus 4. They are equal, but if I added another number to the mix, right? Like if I said, you know what, I'm going to add 5 to 10. Well, now I've made an inequality. It's no longer equal until I took the red side of the equal sign and added 5 to that number as well. Because if I evaluate the left here, I get 15. And if I evaluate the right here, 6 plus 4 plus 5 is also 15. And now I've maintained equality by adding the same number to one side as the other side of the equal sign. Okay? And this would work for subtraction. It would work for multiplication or division as well. You'll get the same exact thing with all four operations. So these principles of equality, like we'll see in that example we're just doing, is there are specific values that you want to force or manipulate into equations, which then allow you to then ignore these values, okay? One of those values is 1. The other is 0. Now we use addition, I shouldn't have used green. We use, technical difficulties. I think I did that right. We use addition and subtraction in order to create, I'll write that in there, to create 0. Yeah, I ran out of space, my bad. So when you need to create 0, you're always thinking in terms of addition and subtraction. On the other hand, when it's time to, I don't know what color to use, guys, gray. When you need to create 1, then you use multiplication or division, all right? So this is you're going to use these two principles of equality to create 1. Now, why these two specific numbers? And math nerds like me, we geek out about these two numbers, 1 and 0. Like, dude, is that the number 1 I see right there? Holy smokes. Or the number 0, right? Oh, wow, that's craziness. Not many people react that way, but I do because I'm kind of a math nerd. But the reason why we want to create 0 is because if I go back to, well, yeah, let's use this expression right here. If I go back to this expression and I said, look, what I really want to do to this expression is add 0, like this. No, I'm going to use the same color. It kind of did something weird on me in there. So if I said I'm going to add 0 to both of these, did I just change the value? No, I didn't. Now, can I manipulate 0? I can, and that's a whole different discussion. But in fact, if it showed plus 0 in the beginning, I could say, what's the difference between me showing plus 0 and then just erasing it completely? Nothing. There's no difference. You could even subtract 0 and you could just erase it, right? Well, the same thing is true for 1s in some cases, so that's why we said create 1. I've got to use a different expression, though. So let's use this one right here. I said, I guess 3. Just 3. I say 3 equals 3. This is a different example. Well, what can I do to 3 to make it equal to 3? Well, I could manipulate it by adding 0 to both sides like this, and the commutative property of addition allows me to put it on either side of the 3, and that's nifty, and that's why math people geek out about 0 so much. But the same thing is true with 1 as long as I multiply it. So if I took this 3 and multiplied by 1 here on the left, and I took 3 and multiplied it by 1 on the right, have I changed the value? No, I have not. So, is there any difference between me showing multiply by 1 and just erasing it completely? There isn't. So, that is why we need to remember these two values, 0 and 1, in relationship to these principles of equality. Addition and subtraction is to create 0, and multiplication and division is to create 1. So, when I look at a problem like this one, sorry, let me slide that down a little bit. I got 26x minus 8 equals negative 15. It should say solve. And we already know that solve means that we need to find a value of x that's going to make this a true statement. So when we solve equations like this, two-steppers or more, what we need is to get the x's on their own, which means that I don't want anything added or subtracted first, right? And this one I got minus 8. It's no good. I don't want minus 8. What I really would like on this is 26x plus 0, right? I want like, 26x plus 0. But right now it's showing as minus 8. Now notice I didn't put anything on the other side of that equal sign because I'm going to manipulate it on my own right here. I don't want that minus 8. I want it to be plus 0. So if I said, well, how do I make a minus 8 a plus 0? Again, I'm just going to use its opposite, plus 8. Now remember, it's an equation, so whatever I do to one side of the equal sign, in order to maintain equality, I got to do it to the other side. So I'm going to have to add 8 to both sides right here like this. Well, yeah, what is negative 8 or this? You guys need to understand right now that's a negative 8, by the way. That's a negative 8 term. I took negative 8 and added 8. I get 0, which is what I wanted. That's negative 15 plus 8, which is now negative 7. Oh, very nice. Now remember what I said about plus 0? We don't need to show that garbage. It's a phantom 0. It's there. It's looking at you. It's watching. You just don't want to see it, okay? Well, now I got a coefficient of x that's 26. I want it to be 1x, though, you guys. Not 26. So how do I make the coefficient of x 1 instead of 26? How do you make a number 1? Well, the best way that I know is just to divide it by itself. So if I took 26 and divided by 26, I'd get 1 right there. Just remember, it still is an equation, so I'd still have to divide it by 26 on the other side of that equal sign. And I'm not going to turn this into a decimal because it's going to be pretty ugly decimal. So I'm going to leave it as negative 7/26. Now I could check in my calculator if I remember to bring one over here, but I forgot though. So you could type this in though. Negative 7/26 times 26 is negative 7. See how the negative 7 came into play when we checked? Negative 7 minus 8 equals negative 15. That is a true statement, and now I know for sure that this is a true state. This value of x would make it a true statement. It's a process. This creates a process for us. If you can just get the x's on their own side of the equal sign, some people say you got to isolate the x's. I like to say you're going to make zeros, right? And this is for two-steppers, by the way. If you can isolate the x's, then all you got to do, it's 2 steps, is divide by the coefficient on both sides of the equal sign, which is when we make ones. Alright, so here's a problem right here. I'll do this one real quick, and then we'll finish up, okay? So I got 15x plus 9 equals negative 4. And remember, I want to isolate the x's, so what I would really like is 15x plus 0 equals something. So I got that plus 9. I need to make it a plus 0, so I'm going to subtract 9. Again, that's 9 minus 9, which would be 0 right there. And again, I don't really need to show that plus 0. I'll make it a phantom 0. Just to stay consistent with the notation right there. But now on the right side of the equal sign, I'll move that over a little bit. I got negative 4 minus 9. And you can put that in the calculator if you need to, but it's going to be negative 13 either way. So I got 15x. So I've isolated the x's. It's on their own side of the equal sign. I made that 0 right there. Next thing I need to do is make a 1. That's the coefficient of x. Just divide both sides by the coefficient, because 15 divided by 15 is 1. And yes, I know I'm showing division with the fraction line, which most people hate. You don't have to. You could show this as a divide sign if you want, like that. But I got 15 divided by 15, which is 1. 1x now equals negative 13 divided by 15, which is negative 13/15. Now I can check. Negative 13/15 times x, times 15, would be negative 13. Negative 13 plus 9 is negative 4, which is true statement. And I'll just box that in, you guys. So it's imperative that you guys understand that all we do when we're making or solving equations is making either zeros or ones. And it's usually in that order, 0, then 1, especially with two-steppers, all right? Now, there's, once we start seeing longer or bigger problems, it'll change a little bit, okay? But once you get it down to this format, or this type of format, it's the same idea every time, okay? So when we see something like this, again, I want it to be not 7x plus 6, I want it to be 7x plus 0, because once I make it 7x plus 0, then I can just erase that garbage. So if I look at this one, I don't want it plus 6, I want it plus 0, so how do I make a 0? Bam, just subtract it from itself, and then it becomes a 0. Now again, I could show the plus 0 if I wanted to, but I'm going to make it a phantom 0 because it's going to make more sense for us. But just don't forget, whatever you do to one side of the equal sign, you got to do to the other side. So negative 8 minus 6 is going to be negative 14. That's going to turn out real nice for us. Now I don't want 7x's. What I want is 1x. I'm creating or making a 1. So how do I make a 1 out of a 7? Just divide it by itself. 7 divided by 7 is 1, and that's a 1. But negative 14 divided by 7 is negative 2. So I get negative 2 equals 1x. Really, it's just x equals negative 2. And if you prefer to write it as x equals negative 2, that's fine as well. It's the same exact answer, you guys. So let's just double check, right? So I got negative 2 in for x. Negative 2 times 7. This is order of operation stuff. Negative 2 times 7 is negative 14. See that negative 14 business? Plus 6 is going to be negative 8. That is a true statement. And now I can box this in with great confidence. So why don't you guys take a minute and try this one out. I'm going to pause the video, and if you guys need more time to do it, just pause it, okay? And then I'm going to show you guys how to do it right now. So again, I've got this negative 5x minus 7 equals negative 2, but what I want is really, and yes, that is a negative 5x, what I really want is negative 5x plus 0, because then I can erase that garbage. So I don't want that minus 7, I want a plus 0. How do I make a 0 out of a minus 7? It's going to add 7 to both sides, right? Negative 7 plus 7 is 0. But whatever I do to one side of the equal sign, I must do to the other side as a principle of equality. Negative 2 plus 7 is positive 5. Now that I have that plus 0 right there, I'm going to erase it for sure, which makes this new equation now negative 5x equals 5. But I don't want the coefficient to be negative 5. I want it to be 1x. How do I make a negative 5 a 1? Just divide it by itself, you guys. That's a negative 5 divided by negative 5, which is 1. And I've shown it right here as well. And on the right side of the equal sign, I've got 5 divided by negative 5, which is negative 1. So I'll make that x equals negative 1, and I feel really good about it. Let's see if we're correct, though. So negative 5 up here. Negative 5 times negative 1 is 5. 5 minus 7. Remember the 5 there. 5 minus 7 is negative 2. That is a true statement. So I've already boxed it in. But now I feel more confident about it. So what about this one? So I'm going to do this one a little different. I'm just going to show it a little different. But I'm doing exactly the same thing. I do not want that plus 9 there. I want to isolate the negative 4x. So I need to get rid of that plus 9. So I'm just going to subtract 9 from both sides of this thing, which makes that a 0. So I'm going to drop this negative 4x to make negative 4x there. And negative 27 minus 9 is negative 36. You can check that on your calculator. I don't always do this right in my head, but I feel pretty good about it right now. Now I've got a negative 4x. I want 1x. How do I make a 1x? Just divide the coefficient by itself. Negative 4 divided by negative 4 is 1x. That's what I wanted. But whatever I do to one side of the equal sign, I must do to the other side. Negative 36 divided by negative 4 is positive 9. Let's double check to make sure this is correct. Actually, before that, I'm going to erase that 1 right there. So I've got up here at the top, negative 4 times x, and I'm saying x is 9. Negative 4 times 9 is negative 36. There it is again. Negative 36 plus 9 is negative 27. That is a true statement, so now I know for sure that x equals 9 would make that equation a true statement. Now this one is written a little different, so you got to be careful on these ones, you guys, because if I said what is the coefficient of a in this specific equation, some of you guys would say 3, but the answer is not 3. The coefficient of a in this case is actually a negative 3, so we have to be careful with how we work with this specific problem. I still want to isolate the a's though, so that 4 that's right there, I don't want it. This is considered a positive 4 right there. Well, how do I make a positive 4 a 0? I just subtract it from itself. So I'm going to subtract 4 from both sides of the equal sign here. Dropping, again, it's not 3a, it's negative 3a. Be careful on that because a lot of students make that mistake. Negative 11 minus 4 is negative 15. So this one's going to give us a nice whole answer, which is pretty good. I do not want negative 3 as the coefficient of a. What I want as the coefficient of a is 1. So if I take negative 3 and divide it by itself, I need to just remember to do it on both sides of the equal sign. Negative 3 divided by 3, and negative 3 is 1, which is what I want, and negative 15 divided by negative 3 is positive 5. So here, a equals positive 5. Let's just double check on this. Now, by the order of operations, I take this negative 3 and multiply it by a, which is 5. Negative 3 times 5 is negative 15. Remember that? 4 minus 15, because I made the negative a minus sign, 4 minus 15 is negative 11. That is a true statement, and I feel really good about boxing this thing in. So problems like this one, hopefully they're not too challenging. Like some of you guys, it's just different, right? Like if you were to rewrite this equation like this, it's the same exact equation, and some of you guys just feel more comfortable having the x's on the left side here. Now, I really hope that it doesn't matter, because we're going to see lots of problems, not only with x's on the right side of the equal sign, but both sides in later sections of this particular module. So I don't want that. I got the 5x. I just don't want it to be minus 5 right there. I want to isolate those x's. So how do I do that? That would be considered a negative 5. If I add 5 to it, then I get 0, which is what I want. I just need to remember to do it to both sides. So negative 25 plus 5 is now negative 20. And this would equal, I'm going to drop that 5x right there. So negative 20 equals 5 times something. What is that something? Some of you guys could do that in your head, but I'm just going to show it with the principles of equality. If I take 5 and divide it by itself, then I get the 1x that I want, which I could just show as x. I just need to remember to divide it on both sides of the equal sign. Negative 20 divided by 5 is negative 4. So this is 5 times negative 4, which is, I'm checking by the way, 5 times negative 4 is negative 20. Remember that right there. Minus 5 is negative 25. That is a true statement. Bam, we're good. Alright, so that completes 2.2. Thanks for watching, you guys. I hope this helps you out. See you in the next one.